Okay. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, I will introduce myself. My name is Kamalia Kurniasari with team 2024-32005. I am an undergraduate student of Information System at PLN Institute of Technology. Okay, so today I would like to present the result of my practicum on two important machine learning algorithms, namely neural network and Q-learning. Okay, in this practicum, I implemented both algorithms using Python in Jupyter Notebook. The first practicum focuses on neural network, especially using the multi-layer perceptron classifier for classification tasks. And the second practicum focuses on Q-learning, which is one of the fundamental algorithms in reinforcement learning. The purpose of this practicum is to understand how these algorithms work, how to implement them, and how to evaluate their performance in solving different types of problems. Okay, so I will begin the neural network practicum first, and after that, I will continue with the Q-learning. But before that, I will share my screen first. Okay, so in here, for the neural network practicum, I used a dataset containing customer reviews of Turkish airlines. The goal of this practicum was to build a classification model that can predict whether a customer recommends the airline service or not. And the target variable in this dataset is recommended, which consists of two classes. The first one is yes, meaning the customer recommends the airline, and the second one is no, meaning the customer doesn't recommend the airline. Before training the model, I performed several preprocessing and exploratory data analysis steps. Okay, so first one in here, I imported several libraries such as Pandas, NumPy, Matplotlib, and Seaborn. Pandas was used for data preprocessing and analysis. NumPy was used for numerical computation. Matplotlib and Seaborn were used to visualize the dataset. And these libraries are essential because they help in data preparation, visualization, and model evaluation. And after that, in here, I loaded the Turkish Airlines Review dataset into Jupyter Notebook. And after loading the um, dataset, I examined the structure of data to understand um, the available feature and determine which columns were relevant to for the classification task. In here, from the dataset in here, we can see in here, the I selected four main columns. There is review body, title, rating value, and recommended. And in here for the selected column. These columns were chosen because they contain the most relevant information for predicting customer recommendation. And the next step was pre-processing. The first one, I checked whether there were missing value in the dataset. And missing value were found in several columns. So I handled them by filling empty text fields with empty string and filling missing value in the recommended column with word no. And after that, I performed feature engineering by creating a new column in here called sentiment based on the rating value. The sentiment categories were rating 1 to 4 as negative, labeled as 0, and rating 5 to 6 as neutral, labeled as 1, and rating 7 to 10 as positive, labeled as 2. This like this. This new feature helps the model better understand customer opinions. Then, the target variable recommended was encoded into numerical values in here. For category no, became to 0, and category yes is become to 1 in here. Since the dataset contains the text data, I combine the title and review body in here into one text column, and after that I transform the text into numerical features using TF-IDF factorization in here. TF-IDF in here converts text into numerical representation so that the neural network model can process um, the dataset. And after uh, pre-processing data, in here I separated the dataset into feature and target. Yeah, into feature and target. Then I split the data into 70% training data and 30% testing data. The training data was used to train the model, while the testing data was used to evaluate model performance on unseen data. And for model training, I used MLP classifier, which stands for multi-layer perceptron classifier, and the model architecture consists of input layer, 3 hidden layer with 150 neurons, and there is output layer for binary classification. And I set the maximum iteration to for 450, so the model had enough epoch to learn the patterns from the dataset. During training, the neural network adjusts weights and biases through backpropagation to minimize prediction error. And after training, I evaluated the model using accuracy score, and the results showed high accuracy for both training and testing data in here, indicating that the model performed well in classification. And to evaluate the model further, I used a confusion matrix, and the confusion matrix in here show 276 true negatives, 67 true positive, 6 is false positive, and 11 is false negative. This means the model correctly classified most of the data, and the model achieved approximately like 75.28% accuracy, which indicates strong performance. And to improve the model data, performed hyperparameter tuning using grid search CSV, grid search CV. I'm sorry, I mean like grid search CV, and several parameters were tested, including activation function, solver, and then um, learning rate strategies. The best parameters obtained were is activation is 10, solve as SGD, learning rate as constant, and hidden layer in here for the size is 150, 150. And the best cross-validation accuracy score was in here was 70. Nah, in here was 70. I'm sorry, was 97 point 38%, and the result showed that tuning significantly improved the model's performance. And from this practicum, I learned the neural network highly effectively for classification tasks, especially for dataset with complex patterns such as customer reviews. And I also learned the pre-processing, feature engineering, and hyperparameter tuning play major roles in improving model performance. So that about the neural network. Now I will explain about the Q learning. Okay. I will continue with the Q-learning practicum. Okay, unlike the neural network, Q-learning doesn't require a data set. Instead, it uses an environment where an agent learns through interaction. In this practicum, the environment used was a 4 by 4 grid world, where the agent's objective was to find the optimal path from the starting state to state the goal state. And the grid world consists of 16 16 states, and there is four possible actions and one goal state, and there is several obstacle states. And the four available actions are move left, move right, move up, and move down. The goal state was set at 15 in here to store learning results. And to store learning results, in here I initialized a Q table in here with dimension 16 by 4. Initially, all Q values were set to 0 because the agent had no prior knowledge about the environment. And in here there's the parameters used in this practicum, where learning rate equal 0.8. There is discount factor equal 0.95, and then there is exploration probability equal 0.2, and there is approach equal 1000. These parameters control how the agent learn from the experience, and the learning rate determines how much new information affect Q value updates, and the discount factor determines how much future rewards are valued. And for the exploration probability, controls how often the agent explores random actions. And then in here, for the training process was repeated for 1000 epoch. At each epoch, the first one, the agent starts from a random state, and then the agent select an action. The agent moves to the next state, and the agent receives a reward. And the last one, the queue table is updated. Action selection uh, use the epsilon greedy strategy, and this means um 20% of the time the agent explores random action, and 80% of the time the agent exploits the best known action. Q values were updated using the Q-learning formula. And through repeated training, the agent gradually learned which action produced better rewards. And for the reward system was designed as follows: positive reward when reaching the goal, negative reward is um, when hitting obstacles, and small penalty for normal movement. And this reward structured in encourage the agent to reach the goal faster, avoid obstacles, and find the shortest path. And after here for the formula, after we training the data, I visualized the learn key values using a heat map, and the heat map showed that states closer the goal had higher Q values, and this indicates that the agent successfully learned which states were more valuable for reaching the goal. And the gradual increase in Q values toward the goal confirmed that the training process worked correctly. And here for the Q table. And finally, in here, I simulated the optimal path using the learn Q table. The optimal path in here found by the agent was 0, 1, 2, 3, 7, 11, and 15. This means the agent successfully learned the shortest and safest route to the goal state. The agent also avoided obstacle states, which proves that the learning process was effective. And from this practicum, I learned how reinforcement learning works, especially through key learning. The agent learns through trial and error by interacting directly with the environment and receiving rewards. And key learning proved to be effective in solving path optimizations problem and teaching agents to how to make better decision over time. Okay, so in conclusion, both of neural network and Q-learning are powerful machine learning algorithms, but they solve different types of problems. And neural network is suitable for classification and prediction tasks using dataset, while Q-learning is suitable for decision making and optimization problems through interaction with an environment. Okay, so through this practicum, I gained a better understanding of both supervised learning and reinforcement learning, as well as their practical implementation in solving real world problems. So maybe that's enough for my explanation about this practicum. Thank you very much for your kind attention, and I'm very sorry if there are any mistakes on my explanation. And the last I say wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.